Today we're looking at angles of elevation and depression. See these references there to the Mapscape Year 9 textbook, Year 10 textbook, even though we're using the other one, all right? Now, what you've got to think is that when you walk around, you look straight ahead of you. So that's your normal line of sight, is to look straight ahead of you horizontally. So pretend this is your eye down here. Angle of elevation is when you've got your head looking straight ahead and then you start looking up. So angle of elevation is the angle between the horizontal, because that's how we normally look straight ahead, well, we're supposed to. And then we'll look up to something. So that's an angle of elevation from the horizontal looking up. Okay? So if you just remember that when you walk around, you look normally straight ahead, then you'll either look up for elevation or look down for angles of depression. You'll either look up at something or down at something, but it's always measured from the horizontal. Okay, no one walks around with their head to the ground. Well, we hope not. You might if you're upset, but, you know. So, angle of elevation is the angle between the horizontal, that's that one, horizontal, and the line of sight when you're looking upwards. So it's like this, angle of elevation, going up. The angle of depression, as I said, you walk around looking straight ahead, then you might need to look down at something. So it's the angle from the horizontal looking down. So angle of depression is the angle between the horizontal line and then you will look down. So the angle of depression is not inside the triangle often. What you'll have to do is alternate angles for angle of depression. Okay? We'll do some examples. Are we okay? So from the horizontal looking up, elevation. From the horizontal looking down is angle of depression. First few have diagrams, and I think the last one, examples don't. So we've got a hot air balloon. It's up here, hovering over an airfield, remains tethered. Tethered means secured, I suppose, with that string. Tethered to the ground by at A. So it's basically this hot, you know, you've seen helium balloons, how you have to hold them down. Okay, same sort of thing with the hot air balloon. It's sort of anchored to the ground with this string. And of course, it depending on the wind, that line, that's the string that holds it, it won't be straight up often. It'll be off to the side depending on which way the wind's blowing. So that hot air balloon's anchored to the ground here, and the rope is 50 metres long. It says a worker standing on the ground at A observes the angle of elevation. Our angle of elevation, of course, is from the horizontal looking up. So the angle of elevation of the balloon is 41 degrees. Calculate the height of the balloon. So sine, cos or tan. There's your right angle triangle. There's our angle. So we've got opposite, we've got hypotenuse, So sine theta is opposite over hypotenuse. So girls, the thing with this is we just have to draw the diagram. Angle of elevation or angle of depression. The trigonometry stuff is the same. Okay? So sine of 41 is opposite, which is h, over hypotenuse, which is 50. So we're working out a side length here, not an angle. What do I write next? H equals h divided by 50. H is sine 41 times 50. Girls, is this a side length I'm working out or an angle? Side. Yeah, so no degrees minutes. It's a side length. So what have we got? 32.80295. Etc. 8029 ... We want it to the nearest metre. These measurements are in metres, so that is metres. So what's it going to be to the nearest metre? Great, 33 metres. Okay, so the height of that balloon is 33 metres. Now, we're going to look at the next question. Okay, I'm going to do my horizontal here in pink. So, from the top of a mountain, or of a tower, sorry, from the top of a tower, that's 115 metres high. So this distance here is 115. The angle of depression. So remember, it's always from the horizontal because we're looking ahead and then standing at the top of that tower and looking down at that fountain. So that angle of depression is from the horizontal looking down. So angle of elevation from the horizontal looking up. So it's good to put arrows on them. Angle of depression from the horizontal looking down. So that angle there is 22. So from the top of a 115 metre high tower, the angle of depression of the fountain is 22 degrees. And find to one decimal place the distance between the fountain and the base of the tower. So girls, that angle is outside the triangle. So that's a horizontal line, and so's that. We have to assume that the ground is horizontal. You've got two ways of doing this. It's easy just to do alternate angles like this. If that's 22, so's that. The backward Z, sometimes forward Z. Alternate. So therefore we put that this is 22. So this angle up here, this is the angle of depression. Then we have to use, can you write somewhere by alternate angles, that this is 22 using alternate angles. So we've got alternate angles, parallel lines. What are the parallel lines? The two horizontal lines. So the horizontals are parallel because they're both horizontal. So the horizontals are parallel. So whenever you've got angle of depression, there is, pretty much very big chance that you're going to use, you'll use alternate angles. So someone's just said that angle of depression from the top will equal the angle of elevation from the bottom, and it does, okay? All right, but if we ask for angle of depression, you need to clearly mark where it is, and then you'll say that is 22 by alternate, okay? All right, so we've got our right angle triangle that looks like this. We've got 22, D, and 115. We have to assume that the tower is vertical and that the horizontals are horizontal, all right? So what have we got? Sine, cos, or tan. There's the angle. Yeah, it's opposite, it's adjacent. So therefore, tan of theta is opposite over adjacent. I mean, you can put it straight away if you want. Tan of 22 is 115 on D. Is that good to have D on the bottom? So what do we do with it? Swap it. D equals 115 over tan 22. And you're still working out a side length, not an angle. And what do we get? So tan theta we want it to one decimal place. What have we got?
284.6.
What did you have before that?
63498.
Okay, 634. So it's 284.6 metres to one decimal place. Okay, we're going to go over to the next page now. Okay, a quarantine station situated on a headland is 475 metres above sea level. So here's the ocean. Here is the headland, and we've got the quarantine station up here. I'll call that Q. Okay, a quarantine station situated on a headland. A headland is like, North Head, South Head, Sydney Harbour, the heads. It's just like a big cliff above the ocean, okay? So a quarantine station situated on a headland is 475 metres above sea level. So do you know where I put the 475? There, that's 475 metres high. Calculate to the nearest degree the angle of elevation of the quarantine station. So angle of elevation is someone looking up or down? So here's the ferry. I can't draw a good ferry. It looks like a boat. It says calculate to the nearest degree the angle of elevation of the quarantine station from a ferry that is 620 metres from the base of the headland. What do I write here?
620.
Yeah, I don't put it in the air there, but I need the angle of elevation. Now this is a right angle. We have to assume that the cliff goes straight up and down, that the sea level is horizontal. Here's the ferry. Do you know where my angle goes? Angles of elevation and depression are measured from the horizontal looking up or the horizontal looking down. That one. Okay? If I wanted the angle of depression, I'd be looking down there. Okay, girls? So we've got that triangle. So you have to find the angle. We'll just go to the nearest degree. Okay. Are we good? So Yeah. So we've got tan theta is opposite over adjacent, because that's opposite, that's adjacent. Tan theta is 475 over 620. Now we're working out the angle. Can you clearly see the difference? The others will be tan and the angle you can put straight in. But this tan of something, it's the unknown. So what do you do to enter it?
Second of time.
Yeah, second function. So you get the tan to the minus 1 function of 475 over 620. So theta is tan to the minus 1 of 475 over 620. Now we just want it to the nearest degree. Your answer will be in degrees. You don't have to do degrees, minutes, seconds if you don't want. What do we get?
37 degrees, 27 minutes, 24.39 seconds.
All right. That would have been about 37.4 something if you don't change it. So who's got the answer without changing? 37 point what?
37.456.
Etc. Now, that's less than 37.5, which ends up being 37, or if you feel you need to, 37 degrees,
27 minutes, 24.39.
24.39 seconds. That's still closer to 37 degrees to the nearest degree. So that's the angle of elevation looking up. So with the next question, during a cricket test at the Sydney Cricket Ground, an airship is hovering above the ground at an altitude of 2 kilometres. Now, an altitude of 2 kilometres, does that mean a straight vertical up-down distance or a distance that's on an angle? It's just straight up and down height. So the straight up and down height is 2 kilometres. It says find the angle of depression of the arena. So find the angle of depression of the arena from the airship if the, well, that's why it's remote controlled. If the horizontal distance between the airship and the arena is 800 metres. So this airship is not directly above the arena. It's 800 metres, a horizontal distance of 800 metres from the arena. So, girls, someone said, Miss, the units are different lengths, are in different units, which they are. So you're either going to go, you either make them both metres or both kilometres. What do you want to do? All right, we go metres. So here is the airship. It's up here, the blip with a whatever. Right, I put 2 kilometres or 2,000 metres. What should I do now? Girls, it's going to be a triangle. Over here is the arena. This is the airship, arena. And I'm going to do a triangle. So, what's this distance along here? I know it's not to scale, so don't worry. What's this distance? It says,
800.
find the angle of depression of the arena from the airship if the horizontal distance. So girls, I can actually do it across here too if I want, the horizontal distance. So I can do 2 triangles if I want. Either that's 800 or this is 800. Girls, if I make this into a rectangle, I can do that. But where's the angle that I want? Is it the one up there or the one down here? Yeah, girls, angle of depression from the horizontal looking down. So sorry, the ship's facing the wrong way. So here. So someone, if it was in this ship, they would look down and see the arena. Do you see that? You're here in the ship, you look down from the horizontal. 800 metres across. Look, you've got 2 options. You can either draw that up triangle, that higher one, like this, or you can just go, or what you can do is just put a dotted line here and do alternate. Is that okay? But you can go that this is the angle of depression. So do you want to use the bottom triangle, the solid one, or the dotted one? We'll go that because we're saying that the altitude's 2,000 metres or 2 kilometres. The horizontal distance is 800. That's the actual angle of depression, and then we do alternate angles. So what have we got, sine, cos, or tan? So tan theta is 2,000 over 800. Why don't you cross off a few zeros? Okay? So theta equals tan to the minus 1. You can change the 20 over 8 to 2.5, isn't it? Or you can just put it as 20 over 8, which is, do we want it to the nearest degree? Yeah.
68.19859.
So you don't have to go DMS. What's that to the nearest degree?
Yes, it's 198.
198, doesn't matter. It's 68.1. What is it to the nearest degree?
68.
68 degrees. Look, you can do DMS, but without changing it, that's just a decimal. And it's just, you just round it like you would normally round any number, where 0.5 is halfway. Okay? Are we okay, girls? So if I was asking you a question like this, you would clearly mark in the angle of depression, and then you can put the alternate angle down there. From a window on the 5th floor of the office tower. I mean, I can do the floors if you want. 1, 2, 3, 4, 5. Sort of, they're not spaced evenly. So from a window on the 5th floor of the office tower, that'll do. A worker observes a ferry, so this is the sea, that has just moored across the street at Circular Quay. The window is 20 metres above the street. So, we know what we're doing? 20 metres. And the angle of depression of the ferry from the window is 21 degrees 40 minutes. Here's the ferry. All right, we know we're doing a triangle, but you've got to tell me where the 21 degrees 40 minutes is. At the top, is it above the triangle or inside it? Angle of depression, this person is got their head at the window and then they look down. So I put a dotted line for the horizontal. That's the horizontal, and the person looks down 21 degrees 40 minutes. That angle is 2140, and then we do alternate. So I write in here that that's the angle of depression. Remember, we look up or down from the horizontal. But then I put that this one in here is 2140. See, if I ask you to mark in the angle of depression, if you just put that one down there without this, I'm going to take a mark off you. So you need to do that first to show me that you know what it means. Angle of depression is from the horizontal looking down, and then you can put this alternate angle in. All right? How far is the ferry from the base of the building? Where do I put my distance that I need to find? At the bottom. So I've got angle. So I'm just, if you want, you can draw it again if it's too messy. So you've got this 21 degrees 40. D is down here and 20 is there. Sine, cos or tan? Do you have the hypotenuse? No. So it's definitely tan because there's no hypotenuse. We've got opposite. We've got adjacent. Okay, so we go. Tan, theta, is opposite over adjacent. Tan 21 degrees 40 minutes is opposite, which is 20, over adjacent, which is D. What do we do now? Yeah, we don't want D on the bottom, so swap. D equals 20 over tan 21 degrees 40 minutes, and we'll just write the answer to one decimal place straight away.
50.3.
So it's 50 point, and what was it before? 50 point,
3430.
yeah. So it's 50.3 metres to one decimal place. I'm just putting approximation signs. Two buildings of different heights stand on opposite sides of the street, 35 metres apart. Where do I put 35? I can put it there. A man standing on the roof of the shorter building don't worry about the height of the man at the moment. Later we'll do some questions like that where we take that into account. Observes the angle of elevation of the top of the taller building as 54 degrees 57 minutes. We walk around with our head straight and then he's going to look up. So which is the angle? Just this one. 54 degrees 57 minutes. That's the angle of elevation looking up. So you need another new line here A new horizontal. We need a new horizontal up there. Now that's going to be 35 metres as well, that distance. So he looks up, 54 degrees, 75 minutes. The shorter building is 75 metres tall. The shorter. Calculate the height of the taller building. So I'm going to draw a separate right angle triangle. You're actually not going to get the height of the building here, but you can work out this h there. You can work out this extra bit. Do you know what you're going to do at the end once you've worked out h? What are you going to do? Add it to 75. So you can't get the whole height, but you can just work out that extra bit. That's 54 degrees, 57 minutes, and we know the base there is 35. Sine, cos, or tan? So we've got tan theta is opposite over adjacent. Tan 54 degrees, 57 minutes is h over 35. What do we write now? H equals degrees, 57 minutes times 35. Therefore, girls, you need to read your questions very carefully in exams. See, once you've done it, you should read the question again, because sometimes you'll forget to add that 75 at the end if you don't reread the question. So what do we get? H is what? What do we get? 47. Someone said 47. 49. All right. I need two people at least with the same answer. 40. 49.892. Whatever. Which is, to the nearest metre, what is that? Now, I'm rounding to the nearest metre because I know I'm adding it to 75. If I was adding it to 75.2, I wouldn't be rounding here. Does that make sense? So it's 50 metres to the nearest metre. So therefore, the taller building, how tall is it? Because you don't want to lose. It's 75 plus 50, which is 125 metres. Now, the only reason I rounded there is because I knew I was adding a whole number to it here. Otherwise, I would never normally round until the end.